Okay, it's time for problems. We'll solve a couple together first, and then you'll do some for assessment. This is called a block, and it contains a pulley. We'll make the approximation that the pulleys are light and turn without friction, and that the ropes and block are light, meaning that their mass is much less than mine. The pulleys turn easily and the rope is light, so the tension everywhere in the rope is the same. Call it T. So, to our question. If my weight is 700 newtons, what force do I use to pull on the rope? The connection above the block supports me and the light ropes and block. If we assume that I'm not accelerating, this connection applies a force roughly equal to my weight, about 700 newtons. Let's draw a free body diagram. The three ropes that support me pull downwards on this connection. If the total force on the connection is 0, then the sum of the tensions in the three section of ropes is 700 newtons. 3T approximately equal to 700 newtons, T approximately equal to 230 newtons.
230 newtons is not a very big force. And that's why I can climb up the rope and still talk at the same time.
In practice, pulleys and blocks are often used to provide extra force. Here's an example.
This set of ropes is one of the things that's pulling the boat along, so it's under quite a bit of tension. For me to trim the sail, it's good to have some leverage.
Wow, that was refreshing. Finally, here's a problem involving circular motion. It's a bit tricky, so we'll do it together. It shows some useful techniques that you'll use in simpler problems, including some problems in the test. Circe the flying pig is the mascot of our second-year laboratory. Let's calculate the time she takes for one circle using just geometry. The distance from her centre to the support point is 0.97 metres. The angle the chord makes with the vertical is 37 degrees. From that information, we want to calculate the period T. How can we do this? Well, here's a strategy. First, we have uniform circular motion, so we can relate the period T to the acceleration. Then we can use Newton's laws to obtain another equation for the acceleration and solve the two equations to get T. Okay, over to you. First, see if you can use the acceleration A to relate the period T to the given information D and theta.